Okay, let us start. Can you see the screen?
Yes, sir.
Okay. Okay, see, actually we are discussing about this maximum influence at a point due to series of concentrated load. And in the previous class, we have seen how to find out the maximum influence using trial and error method. Okay. Now, in using the trial and error method, what we have observed that for trial and error method, at every step, we need to calculate the ordinate of the influence line diagram. So, whenever there is a movement of the load, wherever there is a movement of the load, you need to calculate for that position of the load what is the ordinate of influence line diagram. And this process is very cumbersome because at every position of the load, every movement of the load, you need to calculate the ordinate. And how do you calculate the ordinate? Using the similar triangle only. So using the similar triangle at every step, if you want to calculate the ordinate, the the numerical effort will be too much. However, using this method, you can step by step go and find out how to get the maximum influence at a particular point because of series of concentrated load. Now, on the previous class only we have said that because this process is a cumbersome method, there is another one method, okay, so which is called the change in slope method. And we will try to understand that change in slope method today with some example. And first we will try to understand the philosophy of this change in slope method. So let us see what is actually change in slope method. Okay. So in the next slide you will observe what is change in slope method. So you see that maximum influence of a point because of this what is called this series of concentrated load, if you want to see, then then you then you see then you see that basically your your thing is that actually actually if you observe that whenever there is a maximum influence at a point, at that time there will be some trial and error, and that trial and error is basically very tedious at times. Okay, so to to overcome this trial and error method, you can go for this series of concentrated load. And if you want to go for this series of concentrated load, what you have to do, for the critical position of the load, for the critical position of the loads, how you can determine it? You can determine it in a more direct manner, by just calculating the delta V or delta M. What is delta V and delta M? Delta V or delta M is nothing but the change in shear. The change in shear. That means from position 1 of the series of concentrated load, if the load moves from position 1 to the position 2, in such case what you will have to do, you will have to just calculate the value of the change in the shear force. And if you can calculate the change in the shear force, that change in shear force will give you some indication. And what indication it will give? So suppose the change in shear force from position 1 to position 2, that gives you a value of sign value with a sign of positive. And then when for the next position, that means when the series of loads are moving from position number 2 to position number 3, at that point if you can find out the value of the change in shear, and in such case, that means in the second case, when the load is moving from position 2 to position 3, in that case if you get a value which is negative, then this positive to negative change, that means the positive to negative change, that means from case 1 to case 2 you got a positive value, and from case 2 to case 3 you are getting suppose a negative value. So the at the particular position of 2, when the change in sign for the change in shear force is happening, at that point the position of the load will be critical. When you will be taking a problem and solving it, then you will be understanding it more clearly. But you must understand here at this point that from the trial and error method, this change in slope method is differing in this way, that the change in, because of the trial and error method, what you need to do, you need to calculate at each and every instance of the load the ordinate of the influence line diagram, whereas when you will be doing it using the change in slope method, you need not to calculate the ordinate of the influence line diagram. Rather, what you will have to do, rather you will have to calculate the slope of the influence line. So how do you calculate the slope of the influence line? So the slope of the influence line can be very easily calculated using coordinate geometry things. That is, slope of a line is just given as y2 minus y1 by x2 minus x1. So whenever you are getting a straight line, for that straight line you should be able to calculate the slope of the straight line. If you remember your coordinate geometry, just you take the difference between two coordinates point for x and y, that means y2 minus y1 and x2 minus x1, that is going to give you the slope of that straight line. So when the load will be moving up, when the loads will be moving up that slope of the influence line diagram, at that time you will be considering the slope as positive, whereas when the load will be moving down the slope, then you will be considering those slopes as negative. And how do you calculate the delta V? That means the change in shear. So the change in shear can be calculated using this, that is this delta V. This delta V can be calculated using just by this one, that is the load value and the slope, multiply the load with the slope of the straight line. And what is that straight line? That influence line is basically a straight line. So slope of that influence line multiplied by x2 minus x1. What is x2 minus x1? x2 minus x1 is nothing but the change in position of the load from 1 to 2. That means at the position 1, the load position will be x1, the coordinate of the load will be x1, and at the position 2 the coordinate of the load will be x2. So if you take a difference between that two, multiply it with load and multiply it with the slope, you are going to get how much will be the change in shear because of the load moving from point number 1 to point number 2. Exactly the same way you should be able to calculate when the load will be moving from point number 2 to point number 3. So you must understand here that the influence line slope is very important. So if you see the shear force influence line, you may get different slopes of influence line, as well as if you see bending moment influence line diagram as a whole, then you will notice that the bending moment influence line also consists of multiple straight lines with different equations. So the slope of the equations may be different. So accordingly you will have to use the slope. When you will be taking a problem, you will be understanding it more. And the second thing you must understand, this will be more predominantly coming in case of shear force only, when you will be constructing the uh, influence line diagram for shear force, this will be more predominantly coming. This is the this point, that is when the load moves past a point where there is a discontinuity in the influence line. So what is the discontinuity? So you see, you observe this discontinuity. So you see this is the influence line diagram for shear force. So where is the discontinuity? You see the discontinuity is at this point. Discontinuity will be coming here, right? So this discontinuity, whenever there is a discontinuity, at that discontinuity, what you will have to do? At that discontinuity, you see what you will have to do to find out the value of change in shear. You cannot multiply it by slope, rather you will have to calculate this change in shear by just multiplying the load with the change in ordinate values of that load. That means, you see, when this, I'll just show you here, when suppose one load is coming over here, and then it is moving to this position, at that time what will happen? This load, when it will be passing this position, then you see at this position there will be a drop. So from positive 0.75 it will be dropping to negative 0.25. So there will be a drop of -1, minus 0.75, this will come down, and then further minus 0.25. So there will be a minus 0.75, minus 0.25. So there will be a drop of -1 at this point. So what you will have to do in such case, when there will be a jump of this or a drop of this load along the influence line diagram, at that time what you will have to do? You will have to just multiply the load with the difference in the ordinate, okay? And thus what you will have to do? You use these above equations, okay, to calculate the influence line diagram at a particular point due to series of concentrated loads, okay? So let us now go to a problem and try to understand it. So see, if you remember, in the previous class we have understood this problem using trial and error method. Do you remember? This problem we have understood using trial and error method. So you see, the case number 1, at the case number 1, what we have said? At the case number 1, the load will be exactly coming over this point. And at case number 2, the load will be just moving by 1.5 meter. And when there will be a movement by this 1.5 meter on this side, then you see what is happening. When there will be a movement of this 1.5 meter, then you see this head of this load, that means this 4.5 kilonewton load, when it is staying over here, rather when it is moving from case 1 to case 2, then what is happening? You notice that this 4.5 kilonewton load, when it will be reaching over here, before reaching to this position, it needs to drop by an amount this much, right? So it needs to drop by an amount this much, then it will be rising a slope by this much, okay? On the same time you see this 18 kilonewton load, this will be rising a positive slope along this, and it will be coming over here. And you see this 18 kilonewton load will be just rising another one slope by this much amount, okay? So if you go by this method, then you see in the next slide, according to this methodology, if you go to the next slide, you see this is what actually you need to calculate. So first of all, you see, first what you will have to do? You will have to calculate, you will have to find out the influence line diagram. So you know how to find out the influence line diagram. So this is the influence line diagram you have found out, okay? So once you have found out the influence line diagram, then you observe that the influence line positive ordinate is 0.75 and influence line negative ordinate is minus 0.25. So what will be the slope? What will be the slope? So you observe the slope of this influence line, will be 0.75. So you see y2 minus y1. So if I consider this line, slope of this line, if I consider the slope of this line, and the load is entering from this side, so when the load is covering this influence line diagram, you observe the load is moving the positive slope of the influence line, isn't it? From this 0 to this much slope, it will be rising up. And for this influence line, what will be the slope for this position, for this line? What will be the slope of this line? The slope of this line, you see, it's very simple. It will be y2 minus y1. So y2, value of y2 is 0.75, right? 0.75, and y1 is 0. At this point, what is the value of y1? It is 0. So 0.75 minus 0, and what will be the value of x1? See, the value of x2 will be 12, and x1 will be 3. So 12 minus 3. So y2 minus y1, sorry, y2 minus y1 is going to give you 0.75 minus 0, which is 0.75, divided by 12 minus 3, which is going to be 9, and 0.75 divided by 9, this is going to give you 0.0833. If you calculate, you are going to get this value, okay? And you see there will be a jump. So how much jump you will be having? How much jump will be having at this point? So this is your point C. So at this point, you see you will be having a jump of 0.75 to 25. So 0.75 plus 0.25. So there is a, when the load will be entering from this side, of the beam, then the loads will be rising up by this much amount, and then when it will be crossing this position and coming somewhere here, at that time there will be a drop of the load, right? So when there will be a drop, what you will have to do? You will have to multiply. You see, if there is a drop of load, what you will have to do? To calculate the change in shear, you see, for this delta V, what you will have to do? You will have to multiply the load multiplied by the change in ordinate. Otherwise, what you will have to do? For this delta V, you will have to do load multiplied by slope multiplied by x2 minus x1. Okay. So you see, let me again bring this. Okay, let me again bring this to this slide. Then it will be little bit more clear, I think. You see, suppose I let us bring it to this Word document, then it will be more clear. So can you see this document, Word document? Can you see this?
Yes, sir.
Okay. So let us see. Let us go the top. See, this is what is actually the diagram, right? So you see, when at this position of the load, it has not entered the beam. So what we have said, that because of the point load, whenever there is a movement, series of concentrated load, the loads must come to the maximum ordinate. So the first position, the case 1 position will be this one. So you see, case 1 position of the load is this one, right? So at this position of the load, on the previous class, if you remember, we have done some simulation like this. So if you take 3 loads like this, 1 load and then 2 load and then the third load, something like this, okay? So and then you group these loads together, because you will have to move it together, sorry. So you group it, so you see, these 3 loads together, when it will be moving, So how it will be moving? It will be, you see, it will be first coming over here, and then what will happen? This load will be gradually moving. So when you see, when these loads are gradually moving, you see what is happening. See, this load is moving up the slope, as well as this load will be moving up the slope, as well as this load will be moving up the slope. And at a particular position which we are saying case 1, see, the load will be reaching at this position, isn't it? Load will be reaching at this position. Have you got it? So these three loads will be reaching, sorry, what happened to this? So this load will be reaching this position. So this is your case 1, this is your case 1. Now this, at this case 1, you have some CR at this point C. Now when these three loads together will be moving, so when it will be moving together, what will happen? So the first load will be moving by 1.5 meter, and the second load will be coming over here, isn't it? So when this position is happening, then you see what is happening actually. You see what is happening. You see the load when it is over here, after that this load, this first head load, the head of the load will be fast dropping along this, right? And then it will be moving up the slope and it will be reaching over here. Okay, so when this thing is happening, then you see you are coming from case 1, to case 2. So at that point in time, if you want to find out the value of the change in shear, then how do you calculate? So you see, how do you calculate it? So you see this 4.5 kilonewton load, for very carefully understand this 4.5 kilonewton load, what is happening? At the case 1 position it was here, and at the case 2 position, so at the case 1 position the load was here, and at the case 2 position it has, this 4.5 kilonewton load has dropped by this much amount, and then it has moved a positive slope by this much amount, isn't it? It has moved a positive slope by this much amount. So when this is happening, then this 4.5 kilonewton load will be fast dropping by an amount which is 0.75 plus 0.25. So the drop, when it is dropping down, it will be considered as negative. And if you go to the slide now, you will understand. So see the change in shear, from position 1 to position 2. So when it is moving from position 1 to position 2, you see what is happening? This 4.5 kilonewton load is dropping by 0.75 plus 0.25, and as it is a drop, it will be considered as negative. So first thing what you are doing, 4.5 multiplied by -1, and what is this -1? This -1 is nothing but 0.75 plus 0.251. As it is a drop, it will be taken as multiplied with a minus sign. And how theoretically you understand this? Theoretically, actually you are doing this. So delta B you are calculating P multiplied by y2 minus y1. And what is your y2 over here? Your y2 over here is your basically points, your y2 is your minus 0.25 and y1 is your 0.75. So basically there is a drop, so minus 0.25 minus 0.75, so that is going to give you minus 1. So first you are multiplying this one, this 4.5 kilonewton load with a minus 1. Okay, now what is happening? Now you see when there is a change from this position to this position. So initially the case 1 loads were at this position, and then there is a drop, from here to here, and then there is a rising up. So you see what is happening. See this 4.5 kilonewton load, this 4.5 kilonewton load has risen up this slope, risen up this slope, and you see this line and this line are parallel. Okay, so you see the value of the slope of this line and the value of the slope of this line will be same. So if you can calculate also. So the slope of this line, how do you calculate? The slope of this line you have calculated using 0.75 minus 0 divided by 12 minus 3. Exactly the same way, if you calculate the slope for this, it will be 0.25 minus 0 divided by 0 minus 3. So if you do that, you are going to get exactly the same value of slope whatever you have got over here, right? So here it will be 0.75 by 9. On that other case, you are going to get 0.25 by 3, which will give you nothing but 0.0833. So that means you observe the slope of this line and the slope of this line will be having a value of 0.0833 only. Okay, so now you come to the problem, exactly what you need to do. Because this 4.5 kilonewton load, you observe this 4.5 kilonewton load, what has happened to this 4.5 kilonewton load? Very carefully you observe. So this 4.5 kilonewton load at case 1 it was here, and when it is going to case 2, it is dropping by this amount, it is dropping by this amount, and then it is moving a positive slope, isn't it? So it is moving a positive slope. So this 4.5 kilonewton load, when it is moving a positive slope, you just multiply this 4.5 kilonewton load with this slope value 0.0833, and you see by how much amount that load has moved, by how much distance that load has moved. See, the load can only move by 1.5 meter distance, right? Because once this load is moving by 1.5 meter distance, then only this 18 kilonewton load will be exactly coming over this maximum ordinate 0.75. So the movement of the load will be 1.5 meter. And if you go to the theoretical part, the theory, if you try to understand and see, then you see this is what actually you are doing. So what will be the change in shear? The change in shear will be, in that case, delta V is equal to P. P is the load multiplied by the S, that is the slope, and then x2 minus x1. So P, what is the load here? Load is 4.5, slope is 0.0833, and what is x2 minus x1? See, x2 minus x1 is nothing but the distance the load is traveling. So once the load was here in case number 1, how much distance it has traveled? It has traveled by distance 1.5 meter. So you see that the x2 minus x1 is nothing but the distance between two loads, because it cannot move beyond that much distance. Okay, so once you get this value, you put the value over here. So what you are doing, you just put the value over here. So it is going to be 4.5 multiplied by 0.0833, that is the slope, and x2 minus x1 in this case is 1.5. Okay, now exactly at that same time, when the combined three loads are moving down the slope, moving up the slope, then what is happening? You see, if you come back here again, then what has happened to this 18 kilonewton load? What has happened to this 18 kilonewton load? See, initially this load was here. So this is your 18 kilonewton load, and this is your another 18 kilonewton load. So when this load has dropped, from case 1 to case 2, and then it has moved up, so what is happening? What is happening to this load? This 18 kilonewton and this 18 kilonewton load. You observe what is happening. See, this 18 kilonewton load, you very carefully observe. This 18 kilonewton load, you see, it is dropping over here, and then you see this 18 kilonewton load is basically rising up this slope. You see, it is rising up this slope, and this load is also rising up this slope, isn't it? This slope is also, sorry, see this 18 kilonewton load will be also rising up this slope, and how much, by how much distance it will be rising up? The distance by what it will be rising up is nothing but the distance between these two load and this two load, right? Because you see the distance between these two loads are given over here, that is 1.5 meter and 1.5 meter. So whenever this 4.5 kilonewton load will be moving by 1.5 meter, obviously this 18 kilonewton load will be also moving by 1.5 meter. This 18 kilonewton load will be also moving by 1.5 meter. Okay, so once this is happening, you can easily come back to this slide and you can understand what is exactly happening. You see what is exactly happening. This 18 kilonewton load, thus you can observe it has also risen up a slope of 0.0833. This is the rising up, and then how much, by how much distance is it has moved? It has moved by 1.5 meter. So this is the second load. This 18 kilonewton is the second load, and you see the third 18 kilonewton load, that is the third 18 kilonewton load. So when this load, when the second load has moved by 1.5 meter, this third load will be also moving by 1.5 meter, and you see this load will be also moving, this third load, if you observe, it is also moving up the slope, because it is also moving up the slope. You see this load is also moving up the slope, and how much slope it is moving up? The slope is the slope of this straight line. So the slope of this straight line, it is moving up. So what is the slope of this straight line? The slope of this straight line is nothing but 0.0833. So this is the third load we are considering. So 18 multiplied by 0.0833 into 1.5. Is it clear? So is there any doubt up to this point? Tell me if you have any doubt up to this point. Any doubt? No? No doubt? Hello? Okay. So if you do not have any doubt, let me proceed further. So let's see. See now, for this change in shear for case 1 to case 2, how much value you are getting? So if you simplify this equation, if you simplify this mathematical part, you are going to get plus 0.563 kilonewton. So you are getting a positive value. See, this sign is very important. So you are getting a positive value. So positive 0.563 kilonewton. So this much amount is the change in shear. So since V12 is positive, case 2 will yield a larger value for Vc than case 1. That means when this load is moving from case 1 to case 2, you are getting a positive value. So the position of the load when it is at case 1 and the position of the load when it is as case 2. So when the load is moving from case 1 to case 2, as the value is coming as positive, so the case 2 is going to give you larger value of shear force than case 1. Okay. Now once you have calculated this delta V12 and you got a positive value, you should go for the next case. So what will be the next case? Next case will be nothing but, if we again come back to this document, you see the next case will be your case 3. So what is your case 3? So next case is your case 3, and if you remember case 3 in the trial and error method also we have discussed. At the time when it is coming to case 3, you observe the load will be moving further by 1.5 meter. So when it is moving further by 1.5 meter, what is happening? So load is now over here. You see the load is now, initially at case 2 it was here. So you see when there is a movement of this load, this front load, when there is a movement of this front load by by let's say 1.5 meters. So what is happening? You see it will be moving like this, but you observe very carefully. So when there is a movement of this load, this front load of 4.5 kilonewton, you see there is an 18 kilonewton load, this 18 kilonewton load and this 18 kilonewton load. So you see at case 2 was it, where where it was at case 2, it was here. So when this load will be moving by an amount of 1.5 meter in this direction, then what will happen? Then you see, then what will happen? So first you see, when this load is moving from here to here, you see there will be a drop, there will be a drop, because this 18 kilonewton load, when it will be positioned, when it will be coming and moving for another 1.5 meter, you see this 18 kilonewton load, this middle 18 kilonewton load needs to drop by amount 1, right? Needs to drop by amount 1. So once there will be a drop of this load, once there will be a drop of this load, again you observe this 4.5 kilonewton load, very carefully you observe this 4.5 kilonewton load, this is the head of the load, this is actually moving up the slope, and this 18 kilonewton load will be moving up this slope, but before it is moving up this slope, it will be dropping by another -1, and then this behind 18 kilonewton load, at the end this 18 kilonewton load, you observe this will be actually moving up by that slope, and it will be just coming over here. So if you go to the presentation and you see how you will be calculating, so you see this 4.5 kilonewton load, it has just moved up. So how much it has moved up? It has moved up by that slope, that is 0.0833. And what is the distance it has traveled? It has traveled by 1.5 meter distance. So you see you are going to get another one value. So you see you are forget about the first part. First you see this 4.5 kilonewton load, this has moved up a slope 0.0833, and it has traveled by a distance x2 minus x1 is nothing but 1.5. Now you see what will happen to this, as I have explained to you, what has happened to this 18 kilonewton load. See this 18 kilonewton load, this middle load, you see this middle load, what has happened? When this front load has moved up the slope, you see before this 18 kilonewton load is moving up this slope, before this load is moving up this slope, it needs to drop by an amount this, right? So there is a discontinuity of the shear force diagram. So this discontinuity you will again have to consider. So once you take into consideration this discontinuity, you see you are going to get another one value, and you see this is actually 18 into -1. That means this 18 kilonewton load will be dropping by this ordinate. So there is a jump at C, and this jump at C is nothing but -1. So this is going to give you 18 into -1. And how are you getting it? See if you go to the theory, so this is actually you are using P into y2 minus 1 y1. If the load moves past a point where there is a discontinuity in the influence line, the change in shear is this much. So there is a discontinuity. So how do you calculate the discontinuity shear? You calculate the discontinuity shear using 18 multiplied by -1. And then you see this 18 kilonewton load is basically, after dropping from here, it is again moving up, isn't it? It is moving up the slope. And when it is moving up the slope, how much slope it will be moving up? It will be moving up by another amount 0.0833, right? It will be moved up by another one 0.0833. So it is going to give you 18 multiplied by 0.0833 multiplied by 1.5. Okay, and at the end, the final load, you see this final load, when this is final load, or sorry, this last, the end load, basically this end load, you see when this load will be dropping, when this load will be dropping, and then this load will be moving. So the end load, you notice this, observe this end load, how it is happening. So once this load is coming over here and then it is moving, so there will be a drop and then there will be a move. So you see this load, the end load, if you observe the end load, you see it is moving up this slope, it is moving up this slope, right? So and the slope is exactly the same, so it will be moving up by a slope amount which is 0.0833. So that will be going to be 18 multiplied by 0.0833 multiplied, sorry, come down, 18 multiplied by 0.0833 multiplied by 1.5. Now if you simplify it, see, from case 2 to case 3, what you are getting? You are getting, you observe, you are getting a negative value of the shear. That means change in shear force when the load is moving from the position of 2 to position 3, your value of shear, change in shear, is becoming positive to negative, or you are getting a negative value. That means, you see, when you have moved from 1 to 2, you got a positive value, and then when you move from 2 to 3, you are getting a negative value. So as we have said, in this case the position 2 is going to be the position, this position, case 2 position, will be your critical position of the load, critical position of the loading. Why? Because you see, from 1 to 2 you got a positive value, and 2 to 3 when you are moving you are getting a negative value. So the position number 2 is going to give you the critical position of the load. It is going to give you the critical position of the load. Okay? And once you find out the critical position of the load, for that position of the load, particularly you find out how much will be the value of the shear. And if you find out the value of the shear, that is going to give you the maximum shear because of the series of concentrated load moving on a typical beam at a particular point. Is this clear? Do you have any doubt up to this point? Any doubt? Okay, so let me take the attendance. So Google Meet attendance collector 20, refresh. So attendance is taken. So is there any doubt? Can you hear me? Any no response. I don't know whether you are able to hear or not. Ayan Chakraborty. Hello. Can you hear? Divakar Chakraborty. Hello.
Yes, sir.
Can you hear whatever we have discussed?
Yes, sir. Yes, sir.
So is it clear? I am asking everyone that whether it is clear. No one is speaking. So do you have any doubt? Is it clear whatever we have discussed till
No,
now?
sir.
Huh? No
Yes,
question.
sir.
Okay.
No, sir.
Okay. See, we have still have some few more minutes. So you see, if you remember, I have shared one see you I have shared with you this one, my some problems, okay. So you have this with you, right? So change in slope method we have discussed today, and you will see there is a problem given. Sorry, there is a problem given, okay. For this you please try it, okay, you please try it with your own, okay. See this problem, this problem, this problem number 1, if you see this trial and error method. So there is another one problem. See there is a beam which is 40 meter of length, and there are three loads. The front load is 1 kilonewton, next two loads are 4 kilonewton and 4 kilonewton. They are separated by a distance of 5 meter. They are separated by a distance of 5 meter, and you need to find out, because of this series of concentrated load, what will be the maximum shear at C, okay. So this problem, if you see, we this problem is being solved using both the methods, that is trial and error method, as well as the change in slope method, okay. So if you see the trial and error method or the change in slope method, whatever may be the method, this kind of problem, first thing you will have to draw the influence line for shear force at C, and the influence line for shear force at C, multiple times we have discussed it, and you can step by step understand how to calculate the influence line for shear at C. So if you draw the influence line at shear at C, then you will be getting a diagram something like this, and then this problem is solved using first the trial and error method. You see, for the trial and error method, what you have to do, step by step, if you try to understand, you see, first there will be a case 1. So this case 1 is this one. So the load will be first reaching this maximum ordinate 0.75. So once it will be reaching this maximum ordinate 0.75, you need to find out what are the values of the ordinate. You just multiply those ordinate values with the load, you are going to get how much will be the shear force at that particular position, okay. So this is to find out these ordinates. You see, step by step I have shown you here that using this, if you take this as A, this ordinate as A, this ordinate as B. So you see, from similar triangle of this, you can find out 0.75 divided by this much length. So this is actually 30 meter. From here to here the length is 30 meter, and A is this one, and from here to here it is 5 meter. The distance between these two loads are 5 meter. So the beyond distance from here to here it will be 25. So this way you can find out what is the ordinate of A. So similarly you can find out what is the ordinate of B. So once you find out the ordinates, you can multiply the ordinates with the loads. The loads are nothing but 1, 4, 4. So you multiply 0.75, that is the ordinate, into 1. 0.625 multiplied by 4, that is ordinate at this point is 0.625 multiplied by this 4, and then ordinate at this point is 0.5 multiplied by 4, and then you get 5.25, okay. So once you get this, then you go to the next case. So the next case is the trial number 2. So once you have taken this, then the trial number 2 will be this 1 kilonewton load will be further moving by 5 meters. So once this load will be further moving by 5 meter, then only this load will be, the next load will be coming on the maximum ordinate. So once you have identified the position, you calculate the ordinates again. So you find out what are the ordinate at this position. See, already you have calculated the ordinate at this position, so you need not do again recalculate. So once you find out the ordinate at this position, I have shown you here again how to calculate the ordinate, because you see, when this load will be moving from here to here, if you want to find out the ordinate, you will have to consider this small triangle, okay. So this small triangle, from here to here it is 10 meter. So the maximum ordinate from here to here is 0.25. So 0.25 divided by 10, equal to this ordinate is C, so this is C, and from here to from here to here the distance is 10 meter. The load has moved by come by this much amount, so 5 meter. So this from here to here distance will be 5. So you are going to get 0.25 by 10 equal to C by 5, and you can calculate the ordinate of C. So you must be very clear about this ordinate calculation. It is very simple. You need to just calculate using the position of the load and the similar triangle concept. Okay. So once you get it, you can get the value of the shear at position 2. So you just multiply it with this, and you are going to get the value of this. So here you notice we are applying this minus 0.125, and you must understand why it is minus 0.125, because you see this portion of the influence line diagram we are considering positive, and this bottom portion is this portion is basically negative. So the ordinate from here to here needs to be considered as negative, and ordinate from this above needs to be considered as positive. So once you do it, you are going to get value of VC2 as this. Exactly the same way you observe this when you are getting it. You see this case number 1 you got 5.25, and case number 2 you got 5.735. So you see from case number 2, at case number 2 you are getting more shear than case number 1. Okay. So that means your case number 2 is more critical at this position. Okay. Now you take another one case, that is the case number 3, when this load will be just reaching this position, and once this you do, you go to this position and you just calculate the ordinates with similar triangles. You are going to get a value which is 2.5, and you see this case number 3, when you are coming, you see the case number 3 value of shear force is becoming lesser than this shear force at 2. So what will be your critical position? The critical position thus will be this one. So this is actually the trial and error method, and exactly the same problem is solved. Exactly the same problem is solved, you see, using the change in slope method. Okay. The problem, whatever the problem we have discussed in the slide, it is a different problem, but the methodology is exactly same. So see, you will have to do delta V12, then delta V23, like that. Okay. So delta V12 if you do, so you see delta V12 step by step I have shown you here. Okay. So you please go through this problem step by step. It is being done. Okay, for the shear force. Okay. If you have any doubt, in the next class we will discuss, and we will take up another one problem for this change in slope. How to find out, using this change in slope method, how to find out the maximum moment at a particular position because of the series of concentrated load. If you go through this problem, in just the next problem, if you see the next problem, whatever I have taken, this next problem is given about the moment. We will discuss it in the next class. Okay. Okay. So first you get your concept clear on this shear force problem. Okay. So please work out this problem at home. Okay. And if you have any doubt, ask me in the next class. Okay. Okay. So let us stop here today. Any question, any doubt? Abhishek, any doubt? So should we stop? Hello? Yeah. So we are ending the class today. Okay. If you have no doubt. Okay.
Okay.
Okay. Thank you.